Lecture video will be about the multiple choice question from chapter liquid. The momentary attraction between the molecule of a liquid caused by instantaneous dipole and induced dipole attraction are called van der Waals forces, polar forces, French forces, London forces. So the London forces are the forces of attraction that are momentary and that are present between the instantaneous dipole and induced dipole. So the instantaneous dipole that is produced by the uneven distribution of the electron and positive charge nucleus that will affect or that will induce the dipole in the second atom. So the momentary attraction between the positive of one atom and negative part of the other atom, it is known as London forces. The strength of hydrogen bond is about dash of the covalent bond, 1 by 2, which means half, 1 by 3, 1 by 10, 1 by 100. So first we will know about the hydrogen bond. Hydrogen bond is the bond that is formed between the hydrogen that is attached to the highly electronegative element. There are three elements like fluorine, oxygen and nitrogen, and it will interact with electronegative elements that's like fluorine, oxygen and nitrogen of other molecule. So it is a type of intermolecular attraction that is present between two molecules. Hydrogen of one molecule, it will interact with the nitrogen, oxygen or fluorine of another molecule. It is a temporary bond and it is formed for the short interval of time, and it is a special type of dipole-dipole interaction because the oxygen, fluorine and nitrogen has negative charge, hydrogen has partial positive charge. So there is a temporary type of dipole-dipole interactions, but it is not a covalent bond. The strength of the hydrogen bond is about 1/10 of the covalent bond. So the answer is 1/10. With rise in temperature, the surface tension of the liquid increases, decreases, remain the same, none of the above. The magnitude of the surface tension of a liquid depends upon the attractive forces between the molecule. When the attractive forces are large, the surface tension will be large. So the question is about the rise in temperature. So as increase in the temperature increases the kinetic energy of the molecule, and effectiveness of the intermolecular forces decreases, because with rise in temperature the attractive forces will decrease, and when the attractive forces will decrease, the surface tension will also decrease. So the answer is decrease. Association of molecule in water is due to surface tension, viscosity, hydrogen bonding, optical activity. So hydrogen bonding is responsible for the association of water molecule because it is intermolecular forces of attraction that will associate 2, 3 and more water molecules. In general, the viscosity dash with increase in temperature, decreases, increases, remain the same, none of the above. So when the liquid is heated, the kinetic energy of the molecule increases and the intermolecular become weaker. So the viscosity of a liquid has a direct relationship with intermolecular forces. When it is heated, the intermolecular forces, when with increase in temperature, the intermolecular forces decreases, which decreases the viscosity. Liquid in a container has a temperature 70 degrees C. What will be the temperature on the Kelvin scale? 350 Kelvin, 343 Kelvin, 283 Kelvin, 300 Kelvin. So there is a temperature conversion formula that is from Celsius to Kelvin or Kelvin to Celsius, Fahrenheit to Celsius and Celsius to Fahrenheit, Fahrenheit to Kelvin and Kelvin to Fahrenheit. These all formulas are important for the interconversion of the temperature scale. Now the question is about the finding the Kelvin scale value for degree C given in the question. So the formula will be used, the first formula, Celsius to Kelvin, that is degree C plus 273. 273. So 7 degree C is given, 273 is in formula, and we will get 343 Kelvin. A liquid is in equilibrium with its vapor at its boiling point. On the average, the molecule in the two phases have equal potential energy, kinetic energy, van der Waals forces, total energy. So liquid is in equilibrium, which means that the rate at which the liquid molecule escape from the liquid state and it will become gaseous state, or the rate at which the gaseous molecules strike the surface of the liquid and becomes liquid, are equal, which means that rate of both the processes are equal. So they have same kinetic energy. The potential energy of these both states are not equal because the molecule in liquid and gaseous form have different portions, but they have same kinetic energy because the rate are equal. So the answer is same kinetic energy. Ice float on the surface of water due to large bond length, cubic structure of ice, weak intermolecular forces, and empty spaces in the structure of ice. Ice is less denser than water. When the ice is formed, it will form a rigid tetrahedral structure due to which cage-like spaces remain in their bonding, which is not in the case of liquid water. Due to these empty spaces or cage-like spaces, the volume of the ice increases, which decreases the density. So the empty spaces in the structure of ice is correct answer. The highest temperature at which the vapor pressure of the liquid can be measured is boiling point of the liquid, freezing point of the liquid, inversion temperature, critical temperature. The highest temperature at which the vapor pressure of the liquid can be measured is the boiling point, because at boiling point the vapor pressure is equal to the atmospheric pressure. With any incremental increase in that temperature, the vapor pressure becomes sufficient to overcome the atmospheric pressure and lift the liquid to form vapor bubbles inside the bulk of the substance. So boiling point is that temperature at which the vapor pressure of the liquid is measured. Small droplets are spherical in shape. This is due to high viscosity, their tendency to acquire minimum surface area, their tendency to acquire maximum surface area, less viscosity. Due to surface tension, surface tries to minimize its area. As the sphere has minimum surface area among all geometrical shape, thus liquid droplet which is spherical will have minimum surface area. So the tendency to acquire minimum surface area is the correct answer. The property of liquids, liquid crystal are intermediate between crystals and anisotropic liquid, nematic liquids, isotropic liquid, none of the above. So if we look at this structure, the crystalline form and the isotopic form has in between some structure that is known as liquid crystals, or we can also look at over there, crystal and liquid has in between structure that is the liquid crystal. So the crystal are anisotropic and the liquid is isotropic, and in between there is liquid crystal. So the option is isotropic liquids. Insects can work on the surface of water due to viscosity, surface tension, refractivity, and optical activity. So insect can work on the surface of water due to the phenomena that is known as surface tension. We know that the surface tension is a phenomena in which the surface molecule are in stretch form or in tension form. And this is the property of a liquid which allow it to resist to any external force. So insects can easily walk on the surface of a liquid due to surface tension. What is the correct order for intermolecular forces? The four orders are given in decreasing order. So the intermolecular forces from strongest to weakest are hydrogen bonding, dipole-dipole, dispersion force, that is London forces. So among these options, the strongest is the hydrogen bond, followed by the dipole-dipole and London forces. So A is the correct answer. London forces are present in ammonia, water, kerosene oil, hydrogen chloride. We know that the ammonia, water, these will both form the intermolecular force, that is the hydrogen bond. HCl, it will form the intermolecular force, that is the dipole-dipole type of interactions. Now the kerosene oil is left, which is the correct answer. The primary intermolecular force that are present in most oil and many organic liquid are made from the carbon and hydrogen bonds, hydrogen atoms, and are referred to as non-polar liquids. And the forces that are present is London dispersion forces. Viscosity of hydrogen fluoride is greater than water, less than water, equal to water, none of these. So hydrogen fluoride is less viscous than water due to the presence of strong hydrogen bond in water as compared to HF. Each molecule of water will make up to 4 hydrogen bond, while each molecule of HF will make only 1 hydrogen bond. So due to the greater number of hydrogen bond between the water molecule, it will make the water more viscous as compared to HF. So the answer is less viscous than water. Vapor pressure of the liquid depends upon nature of liquid, temperature, both A and B, none of these. Nature of the liquid mean the intermolecular forces that are present between the water molecule. If there are stronger intermolecular forces, the vapor pressure will be lower. And the temperature, with increase in temperature, the vapor pressure will be increased. So these both factors affect the vapor pressure of the liquid. So both A and B is the correct answer. The number of molecules in 1 dm cube of water will be, there are 4 options given for the molecule. So we will solve it. 1 dm cube is equal to 1 liter, and 1 liter of the water weight 1000 gram. Molecular weight of the water is 18 gram per mole. So 18 gram is equal to 1 mole. So 1000 gram will be equal to the how much of mole, that will result in 55.559 moles. Now the mole has formula that is equal to the number of molecules divided by Avogadro number. The number of molecules are mole multiplied by Avogadro number by rearranging this formula. So the mole is also given, the Avogadro number is constant number, we will get this number. So here in this in these option, the 55.6 and into Avogadro number, it is the correct answer. A liquid crystalline state exists between two temperatures, melting and dash temperature, boiling, freezing, clearing, all of these. So the crystalline state, after melting temperature, it is converted to liquid crystal, and liquid crystal after passing through clearing temperature, it is converted to isotropic liquid. So the liquid crystal is that state that is in between the melting temperature and the clearing temperature. So the answer is clearing temperature. At 1489 millimeter of mercury, water will boil at 120 degrees C, 98 degrees C, 100 degrees C, 90 degrees C. With an increase in the boiling point, mean external pressure is increased. So here the external pressure is increased, which means that the water will boil at temperature above 100 degrees C. 760 millimeter of mercury is for 100 degrees C. So 1489 will be for 120 degrees C. Water has maximum density at minus 4 degrees C, minus 1 degree C, 0 degree C, 4 degree C. So water has maximum density at 4 degrees C because that when the temperature is increased from 0 to 4 degrees C, some of the hydrogen bond break and the molecule come closer and density increases till 4 degrees C because the volume decreases. When the volume decreases, the density will increase. So 4 degrees C is the correct answer.